Section 6.2, Day 2, the second day of transforming and combining random variables. Today we're going to focus on combining random variables. After this section, you should be able to combine random variables and calculate the resulting mean and standard deviation. Also calculate and interpret probabilities involving combinations of normal random variables. Think back to yesterday's example of Pete's Jeep tours. We're going to let X be the number of passengers on the randomly selected trip for Pete Jeep's tours, and Y we're going to let be the number of passengers on a randomly selected trip of Aaron Adventures. We're going to combine the two and define T as X plus Y. So what will the mean and variance as well as standard deviation of T be? Here was the distribution of Pete's Jeep tours from yesterday. And here now is the distribution of his sister Erin and her tours. How many total passengers can Pete and Erin expect on a randomly selected day? Since Pete expects a mean of 3.75 per day and Erin expects a mean of 3.10 per day, they will average a total of 6.85 passengers per trip. We can generalize this result as follows. The mean of the sum of the random variables. For any two random variables x and y, the total of x plus y will give you an expected count or value of t that is equal to the mean of x plus the mean of y. In general, the mean of the sum of several random variables is the sum of their means. We want to consider how much variability is there in the total number of passengers who go on Pete's and Erin's tours on a randomly selected day. To do this, we need to find the probability distribution of T before we calculate that. The only way to determine the probability for any value of T is if x and y are independent random variables. So if knowing whether any event involving x alone has occurred tells us nothing about the occurrence of any event y alone, and vice versa, then x and y can be considered independent random variables. Probability models often assume independence when random variables describe outcomes that appear unrelated to each other. You should ask whether the assumption of independence seems reasonable. In this investigation, it's going to be considered reasonable to assume x and y are independent, since we're saying the siblings operate their tours in different parts of the country. This would be different if the stores were side by side. Again, to be able to calculate the variance, I would have to come up with the entire distribution for t. So t again is x plus y, and here are all the possible combinations of x plus y. For example, you can see here for Pete's Jeep tours, the probability that 2 would be on the tour is 0.15. For Erin, the probability of 2 would be 0.3. So the total would be 4. And the probability would be the 0.15 times the 0.3, which gives you 0.45. All of these values could have been determined using a tree diagram as well. At the right, you can see the distributions for the total. Recall that the mean of the total was 6.85. Now, if I want to find the variance, remember it is the sum of each total outcome minus the mean of the total squared times the probability of that individual outcome. So if I were to calculate this, I end up with 2.0775. That is variance. The standard deviation then would be the square root. But let's take a look at the variance for a second. Note, the variance for Pete's Jeep tours was 1.1875, and the variance for Aaron's Adventures was 0.89. The question is, what do you notice about the variance of T? And hopefully you can see that the variance of T is equal to the sum of the variance from Pete's and from Aaron's. As the preceding example illustrates, When we add two independent random variables, their variances add together. Standard deviations do not add. To find standard deviations, you must do the calculations from the variances. So for any two random variables, x and y, when you're adding them together to get the total, the variance of the total will equal the variance of x plus the variance of y. In general, the variance of the sums of several independent random variables is the sum of their variances. Remember that you can add variances only if two random variables are independent, and you can never add the standard deviations. We can perform a similar investigation to determine what happens as we define a random variable as a difference of two random variables. We're not going to. I'm going to summarize the findings below. The mean of the difference is calculated by mu sub x minus mu sub y. So in general, the mean of the difference of several random variables is the difference of their means. The order of subtraction here is important. For variance, for any two independent random variables, again, you must have independence. The variance for d is, the variance of d is equal to the variance of x plus the variance of y. This time the variance is not a difference. In general, the variance of the difference of two independent random variables is the sum of their variances. So far we have concentrating on finding rules for means and variances of random variables. If the random variable is normal distribution, we can use the mean and standard deviation to compute its probability. An important fact about normal random variables is that any sum or difference of an independent random normal variable is also a normal distribution. So here's an example. If Mr. Starnes selects 4 packets at random, what is the probability that his tea will taste right? So I'm defining x as the amount of sugar in one randomly selected packet. Then I'm defining t as the sum of 4 packets that are randomly selected. And I want to find the probability that the total will be between 8.5 and 9, so that Mr. Starnes' tea will taste right. So I need to find the mean, the total of the 4 packets. So I'm going to add 4 of the means together. Well, this value is the same because each packet comes from a normal distribution with a mean of 2.17 grams. So if I add 2.17 to itself 4 times, I end up with 8.68. Again, I'm given the standard deviation of this case as 0.08. So the variance of the total will be equal to 4 of the variances of my random variable x added together. So if I take 0.08 and square it and add that value together 4 times, I end up with 0.0256. And if I take the square root to obtain my standard deviation, I end up with 0.16. So now, if I take this information and I standardize both the lower value of 8.5 and the upper value of 0.9, I end up with z values of negative 1.13 and 2.0. So I'm trying to find the probability that now z will be between negative 1.13 and 2.0, as is indicated in the picture at the left. If I use the z-table in the back of the book, for a z-score of negative 1.13, my p-value is 0.9772, and for a z-score of 2, it's 0.1292. So if I subtract 0.9772 minus 0.1292, I end up with 0.8480. That means there is about an 85% chance that Mr. Starnes' tea will taste right. Let's take a look at another example. Tom and George are playing in the club championship. Their scores vary as they play the course repeatedly. Tom's scores, we'll call x, have a normal distribution of 110 with a standard deviation of 10. And George's scores vary from round to round according to a normal distribution of 110 with a standard deviation of 8. We'll call that y. If they play independently, what is the probability that Tom will score lower than George and thus do better in the tournament. The distribution of x minus y will be a normal distribution. So here is a picture that represents the distribution for Tom with a mean of 110 and a standard deviation of 10. And here's the picture that represents George's scores with a mean of 100 and a standard deviation of 8. And I want to find the distribution that will be the difference between the scores, which I'll call T. The mean for T will be the mean of x, which are Tom's scores, minus the mean of y, which are George's scores, which would be 110 minus 100, which would equal 10. So I'll fill that in on my distribution over to the right. To find the standard deviation of my total, I need to do it from variance again. So the variance of the total will equal the variances of x plus the variance of y. So the variance for the total will equal 164. To find the standard deviation, I'm going to take the square root of 164, and that ends up being 12.8. Now if Tom and George tie, the difference in their scores would be a 0. If Tom is going to score lower than George, what I'm then trying to find is the probability that my total score, when I do the subtraction, will be less than 0. So what I'm going to do from this point is standardize this. So I need to find the z-score that would correlate to a score of 0 here with a mean of 10 and a standard deviation of 12.8. So z will equal 0 minus 10 divided by 12.8, giving me a value for the z-score of negative 0.78. Using the z-table in the back of the book, that z-score yields 0.2177. So in context of the problem, there is about a 21.8% chance that Tom will score better in the club championship versus George. In summary, remember, a linear transformation of random variables involves adding a constant a, multiplying by a constant b, or both. If we write the linear transformation x in the form y is equal to a plus bx, the following about the distribution is true. The shape will be the same as the probability distribution of x. The center, mu sub y, will equal a plus b times mu sub x. So you take the mean of the original distribution, multiply it by b, and add a. And the spread, standard deviation sub y, will equal the absolute value of b times the standard deviation of x. That is when you're dealing with one distribution and just doing a linear transformation upon that distribution. If you're combining two random variables, if x and y are two random variables, mu sub x plus or minus y will equal mu sub x plus or minus mu sub y. This is how the formula will appear on your formula sheet that you'll get to use on the test. If x and y are independent random variables, and again you can only use this formula if they are independent from one another, sigma squared sub x plus or minus y will equal sigma sub x plus sigma sub y. And again, it does not matter if you're adding or subtracting the distributions, you'll always add the variances together. And again, to get the standard deviation then, you would just take the square root of the variance. And the sum or difference of independent random normal variables will follow a normal distribution. That's it for section 6.2. Section 6.3 will be on two distinct specific types of random variables. One will be known as a binomial distribution, and the second a geometric distribution.